name's Hans Naake, and I'm a geology student at the University of Cincinnati. I'm standing here in Sharon Woods, a park north of Cincinnati. It's February, but you wouldn't be able to tell. The sun is shining, there's green grass. Overall, it's a great day to be outside. I mean, it's not like I'm standing on a sheet of ice in a blizzard, right? But I wonder what the weather was like on this spot 20,000 years ago. I'm willing to bet that it was a lot worse than it is today. That's because on this very spot 20,000 years ago, we would have been at the end of a gigantic ice sheet that started up at the North Pole, covered everything in between, and stopped right here in Cincinnati. So I think I'd be dressed a little bit warmer if the climate was the same today as it was 20,000 years ago. But maybe you're wondering, well, how do you know? I mean, I've experienced some seriously cold weather here in Cincinnati. It was below zero earlier this winter, and you weren't around to measure it, neither was anyone else. So what makes you think there was a gigantic sheet of ice that ended right here in Cincinnati? Well, luckily, there's an entire field of science dedicated to studying what the climate was like in the past. It's called paleoclimatology, and while some of the people that study paleoclimatology are pretty old, none of them were around to measure anything during the time periods that they study. For this reason, paleoclimatologists use something called proxy data to learn about climate in the past. Proxy data, or just proxies, are a special type of information that substitute for direct observations. They allow us to reconstruct past climate without being able to make direct observations. As a matter of fact, the way that we know that I'm standing where a gigantic ice sheet once ended is through the use of a proxy. Below my feet, under a few inches of modern soil, is a material called glacial till. It's made up of all kinds of different sizes of particle, from gigantic boulder-sized rocks to tiny little pieces of clay. And it's only made in one way, through gigantic ice sheets pushing material all around. We could go to the end of any glacier on Earth right now and find this exact same stuff. If we look at a more zoomed out view, like in this geologic map, we can see that the glacial till is deposited in a telltale pattern called moraines. And we could see this pattern at the end of any glacier on Earth today. So, while we can no longer observe the ice that deposited this glacial till, the glacial till is still here. Therefore, the glacial till is acting as a proxy for the ice that was here 20,000 years ago that we can no longer observe. Pretty neat trick if you ask me. I mean, it only kept me coming back for 6 years to learn more. So now you're probably wondering, well, that's all pretty cool, but so what? I mean, who cares if there was ice here, there, or anywhere? Well, while we're lucky enough to have all these really cool ways to use proxies to learn about what happened in the past, it's physically impossible to make any measurements about things in the future that haven't happened yet. For this reason, we need to learn about patterns from the past to be able to predict what might happen in the future. When studying something like climate that changes so drastically over time, it's critical to have as much information as possible about past patterns to best understand how it might change going forward, which is what we really care about. So, I hope with this video you've learned a little bit about how much climate can change through time, how paleoclimatologists use proxy data to learn what the climate was like in the past, and why we want to study climate and learn what it was like in the past to figure out where it might go in the future. And maybe you're just a little bit appreciative that we don't live at the end of a giant ice sheet anymore.